Hey friends, today I'll discuss with you a very important article, capacitance of parallel plate capacitor with a dielectric slab. Okay, let this is a parallel plate capacitor having plus Q charge and minus Q charge. You know very well the formula of parallel plate capacitor. Permittivity of free space, because there is no space, it is a free, no medium. A is the area of each plate of the capacitor, and small d mean that the distance between the two plates. Now we are going to insert a dielectric. You know very well dielectric cannot conduct electricity. It is a type of insulator. So a question comes in your mind: what the difference between insulator and dielectric? So you just go to my video, the special video. I explained there the difference between the dielectric and insulators. Okay, but here you remember, whenever you put a dielectric, so this is a dielectric, of course it cannot conduct the current. So this is a dielectric. When we put it in a field of a capacitor, what happens? Some induced charge appears, some induced negative charge appears here, and some induced positive charge appears here. And what is the magnitude of induced charge? It depends upon it varies from dielectric to dielectric. But of course it will always be less in magnitude as compared to this charge. It is sure. Now there are two fields. One is the external, positive to negative E naught vector, and other is a polarizing field in the dielectric, positive to negative. We call it EP. Now if I say in a dielectric there are two fields, one is external and second is internal. Like if the external is 100 unit and internal is 20 unit, what happen? If external is 100 unit of electric field, internal is 20 unit, what left? Equals to 80 unit. And what will be the direction of this field? Because this is bigger in magnitude, mean external. So 80 unit left and direction will be the external. So I write it here, the net field E vector, it is E naught vector. Of course in vector notation we put a sign of the addition, but because of opposite sign in magnitude, the E becomes equals to E naught minus EP. This is the resultant field, which is, it is having the same direction as that of, that of E naught. So this is the resultant field. Now next there is a definition of the dielectric constant or relative permittivity. Dielectric constant or relative permittivity of the dielectric. So it is a ratio. What is the field without dielectric, which is E naught? Now what is the field in the presence of the dielectric? Like that it is E. So E naught is always greater than E, because E is always reduced. This is always reduced. So K or epsilon R is always greater than 1. Okay, it is always greater than 1. So I use a symbol K here. Right? Now Now we write what about the potential? Now there is a relation between electric field, potential and distance. Now the relation of the potential becomes E naught is existing in a space d minus t and E is existing in the space t. So this is the resulting potential. Now from here E naught may be taken as common. E naught t minus t plus t, okay, because E naught is taken as common. So this E naught comes here and this E, I am writing it here, no problem. So this bracket. So potential becomes E naught into d minus t plus t upon k. Now this electric field is related with the surface charge density by Gauss theorem. E naught is sigma upon epsilon naught. So d minus t plus t upon k. Now sigma is what? Sigma is q by a. Q by a epsilon naught d minus t plus t upon k. Okay. Now capacitance and charge and potential, they are related. So C is equals to Q by V. Substituting V here. So this becomes Q upon A epsilon naught comes here and here left d minus t plus t upon k. This Q and Q goes. So the capacitance becomes epsilon naught E upon d minus t plus t upon k. Okay. Now C is equals to epsilon naught E, right? D minus t may be taken as common. So it becomes 1 minus 1 upon k. Right? Now you remember the formula of parallel plate capacitor. C is equals to what that? Epsilon naught A by D. Now this formula was C naught. I am writing it C naught when there was no dielectric. When there is dielectric, this is the formula. So comparing the two. So C upon C naught becomes epsilon naught A goes. Okay. C upon C naught becomes D upon d minus t 1 minus 1 upon k. If the whole space of the capacitor is filled with the dielectric, then T becomes equals to D. Then C upon C naught becomes D upon D minus D 1 minus 1 upon K. So this becomes equals to D upon D minus D plus D upon K. So this goes. So that becomes D into K upon D. D cancels. So answer becomes C upon C naught equals to K. That if the whole space is filled with dielectric, then capacitance becomes K times the capacitance before when there was no dielectric. So capacitance increases by K times. Whatever the dielectric constant of the medium, it increases that times the capacitance when there was no dielectric. Okay, thank you.